Welcome! In this series of videos, we will look at software add-ons for both the PowerBasic console and Windows compilers. Today we will look at how you can encrypt parameters passed to your CGI application on the Abyss web server. This was our application at the end of the last video. We had created two applications. A web portal to allow the user to execute that application, which would then pick up the username, the computer name and the domain. This would then be passed to the website running on Odroid number 7. This CGI application on the website would strip out these parameters and display them on the screen back to the user in their browser. However, as you will see on the URL, the parameters we are passing to the CGI application are in fact in plain text. They are not encrypted. So our first task today is to find a method by which we can encrypt this data. To do this, we're going to first make the change to the web portal itself. We need to include and use a new library, the Web Encrypt library. So I put a reference at the beginning of our code to the web encrypt.include file. Immediately before that, I've set a string constant, which is going to be our password to be used to encrypt the data. Obviously, with all passwords, you want a really good and difficult to guess password. However, the user will never see this password because it will be inside your binaries. Now we have to encrypt the parameter string. Immediately after the building of the parameter string, where the user, computer and domain have been added, we'll add a line of code to call a function within our new library. This function takes two parameters, the first being the password and the second the parameter string that you wish to encrypt. And the function doing this work is called encapsulate_encrypt. And this single line of code is all we need to do to our web portal. So we will compile that and move on to the CGI application itself. And within that application we have to make the same change. We have to add in our new library, Web Encrypt, using the same password. We're receiving the parameter string into this variable, first parameter. At the moment it is encrypted, so we're going to call another function within our new library called encapsulate_decrypt. It, as the other one did, takes two parameters, first being the password and the second the parameter string that we wish to decrypt. This function, having turned the string back into something we can actually use, is then passed to the next line of code, which then parses out the username, the computer name and the domain. So that's all we need to do to the CGI application, so let's compile that one now. Having compiled our applications, we now have to copy them over to Odroid number 7, the web server. So we'll copy the CGI demo first. And as we're storing the web portal application on a shared folder on Odroid 7, we'll need to copy that as well. And that's it copied. So now we're connected to Odroid number 6. This is the client computer we're going to be using to access our website. And on screen is the shared folder containing the webportal.exe. If we just double click on that exe now, it will launch our splash screen and then straight into the web page. And as you can see from the URL, we're still calling cc_cgi demo exe. However, the parameter string after the question mark is now encrypted. And the output on the browser is showing the user, the computer and the domain. So we've now successfully encrypted our parameter string. However, the website is still HTTP. It's not secure. We want to now switch our web server to being HTTPS, and we'll need to perform some changes within the web server configuration. So we will remote connect to Odroid number 7 to make these changes. So here we are connected to the Abyss web server console to make our changes. At the moment it's configured to use HTTP. So there are two areas of configuration we have to work on. The first is to generate and install a self-signed SSL certificate. Firstly, click on the SSL icon. Now we have to add a new private key, and we'll give that private key a name. Our action here is to generate a key, and we'll leave it at 2041 bits, which is the recommended one. And we'll hit the OK button. Abyss will now generate a new key. Next we have to go into the certificate store and add a new entry. So we have picked console key, which is the name I set for the private key, and we're clicking on self-signed. And we're now going to put in the host name. This is the host name that we will connect to. So if this was a website, it would be www. and then the domain name. In our case, we're just going to make this Odroid 7. And we're setting the country code, in this case, to be GB. Now that we've generated this self-signed certificate, we now have to assign the certificate to a host. So we'll hit the OK button. And we'll go into the configuration. And the general button. And now we can switch the protocol from HTTP to HTTPS. And it's already picked our test certificate, as it's the only certificate in our certificate store. And we will now click OK. Abyss has now realised that we've changed our configuration and we need to click Restart. So we can now wait a moment while the web server process restarts. So now that we've changed our protocol on the web server to be HTTPS, we'll need to change our web portal application. And we can do that quite easily by just changing the URL and recompiling. And we will copy this updated web portal exe onto our shared folder. And now we've achieved that, we can now go back onto the Odroid 6 machine and test it again. We can double click on the web portal application in the shared folder on Odroid 7. This will launch our browser, and since we're using Chrome, it will report here that the connection is not private. Even though we set a certificate up, it's not yet trusted by this local machine. So if you right click on the Not Secure, and then select Certificate is not valid, go to the Details tab and click the Export button. This will allow you to export the certificate. As this is purely a local intranet, it's quite safe to do this since you're under full control of the entire website. We then have to go into Settings on the Chrome browser, search for Certificates, click on Security, and if you scroll down you'll see there's a section entitled Manage Device Certificates. We can then attempt to import the certificate we've just downloaded. We can then import the certificate to our trusted root certificate authorities. It will give you a warning that you're trying to import a certificate from a certification authority claiming to represent the Odroid number 7 computer. In this case, as this is our computer and our certificate, we're going to click Yes. And it says the import was successful. We can now close down the browser and attempt to open our portal once more. And as it launches, it will come up without giving us any message regarding certification. So what we've achieved is to use the Abyss web server to generate a certificate, so we can connect to the website using HTTPS. We've then exported that certificate to a file and then imported that to our browser to allow the Chrome browser to connect to the website without giving you an error regarding the certification. So in summary, we now have a web portal which identifies the user and then connects to the Abyss web server on HTTPS and displays the information passed in the parameters as encrypted data, de-encrypts it and then displays it on the screen. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.